Hello everyone, my name is Joshua Smith and this is my demonstration for the BotanBot Seeder robot, which is part of the BotanBot autonomous farming system developed by Team Salamanders. The BotanBot Seeder is responsible for autonomously planting seeds in both greenhouse and open field environments. In this video, I'll walk through the TinkerCAD circuit simulation and demonstrate how the algorithm controls each sensor and actuator. For a quick overview of the circuit, we have our Arduino Uno, which is the main controller running the planting algorithm. On the breadboard, we have an HC SR04 ultrasonic distance sensor for obstacle detection. We have 3 potentiometers standing in for sensors that aren't natively available in TinkerCAD. The first proxies are soil moisture sensor. The second proxy is the force sensitive resistor that confirms planting depth. And the third proxy is the hopper level sensor. We have 3 servo motors, one for the soil probe arm, one for the furrow tine, and one for the dispensing gate. We have a DC motor and an L293 Delta motor driver, representing the track drivetrain. And finally, 3 LEDs, green for navigating, yellow for the planting cycle, and red for warnings. Here's a quick scroll through the full Arduino code so you can pause and read if you'd like to. The code implements a state machine with 8 states that mirror the planting algorithm from the flowchart. I'll be demonstrating each state live very shortly. Alright, let's start the simulation. The robot will start in the navigate state. You can see the green LED will be lit. The DC motor is running, driving the tracks forward, and the robot is counting time until it reaches the next planting position. Now let's simulate an obstacle by reducing the ultrasonic sensor, reading below 30 centimeters, which is our obstacle threshold. The robot will immediately stop the motor and switch to the obstacle stop state, and the red warning LED will turn on. It will wait here until the path is clear. When the path clears, it detects the distance is safe again and it'll resume navigation automatically. The robot will now enter the check moisture state. You can see the yellow LED will be active, indicating the planting cycle has begun. The probe arm servo will lower to take a moisture reading. And I'll set the moisture reading to low, which will simulate dry soil. Let's watch what happens. The robot will log this position as skipped, and then raise the probe arm and return to navigation. It won't waste a seed on dry soil. Now let me turn the moisture potentiometer back up to simulate adequate soil moisture. When soil moisture is acceptable, the probe raises and the robot will proceed to lower the furrow tine. The tine servo descends to create a furrow in the soil, and then the robot is now in confirmed depth state, reading the force-sensitive resistor, which is being simulated here by the FSR potentiometer to confirm that the tine has reached the correct planting depth of 2 to 5 centimeters. With the depth reading low, the FSR hasn't confirmed target depth yet. So let's set our depth to a bad reading, and then our serial monitor should print depth not reached, retrying on each loop. And now I'll bring the depth back up to the correct level, and the FSR threshold is met, and the robot will confirm depth and move on to the next state. With depth confirmed, the robot will enter the dispense state. The dispensing gate servo opens to release a single seed into the furrow, and then it'll close again. You can see the seed count increment in the serial monitor. Then the tine servo will raise back to its home position. The passive roller at the rear of the robot will naturally compact the soil over the seed as the robot moves forward onto the next navigation cycle. After each planting cycle, the robot will check its hopper level using the third potentiometer proxying the physical hopper sensor on the real robot. I'll simulate a nearly empty hopper by turning this reading below our low threshold. The robot will detect that the hopper is low and it'll switch to a return dock state here. The red warning LED will activate and the track motor reverses to drive the robot back along its row to the docking station after a simulated refill. So we'll refill our hopper here. It resumes planting automatically. And that will cover the full BotanBot Seeder algorithm from navigation and obstacle detection through soil moisture checking, furrow creation, depth confirmation, seed dispensing, and autonomous refill. Every sensor input drives a real state change, and every actuator responds to the algorithm exactly as designed in the flowchart. Thanks for watching, and I hope you enjoyed this presentation.